Drilling engineering, from a regulatory perspective, is not only about how a well is drilled. It is about whether the well is planned, constructed, operated, suspended, and abandoned in a way that protects people, groundwater, the environment, and long-term containment.
That means the life cycle matters. Exploration, appraisal, drilling, completion, production, intervention, suspension, abandonment, and decommissioning are connected regulatory decisions, not isolated technical stages. The central regulatory message is continuity. A design decision made before drilling can affect well control during drilling, casing and cement performance during production, and containment after abandonment. So the regulator is looking beyond immediate operational success. Exactly. The regulator assesses whether risks have been identified, whether controls are suitable, and whether the operator can demonstrate that those controls remain effective through the life of the well. Safety is the first test of that approach. Kicks, blowouts, fires, and loss of containment are not abstract risks. They are foreseeable events that require barriers, procedures, trained personnel, and emergency response capability. And those barriers begin with primary well control. Correct. Mud weight, pore pressure prediction, fracture gradient, kick tolerance, and real-time monitoring all support the safe pressure window. If primary control fails, secondary systems must be ready. Blowout preventers, accumulators, choke manifolds, kill lines, and controlled well shut-in procedures. That is where rig equipment becomes regulatory evidence. Yes, mud pumps, shale shakers, desanders, degassers, mud gas separators, drawworks, hoisting equipment, annular preventers, ram preventers, and adjustable chokes are not simply operational hardware. Their design, testing, maintenance, and readiness are part of the safety case. Well, integrity is the next core obligation. A well must maintain containment during drilling, production, intervention, suspension, and after abandonment. That puts casing and cement at the center of the regulator's attention. Casing supports the wellbore, isolates formations, protects groundwater, and provides the structural pathway for wellhead and pressure control equipment. Cement provides zonal isolation, casing support, corrosion protection, and a barrier against fluid migration.
The regulator would not just ask whether casing and cement are present.
The question is whether they are designed for the expected pressures, installed correctly, tested, monitored, and maintained. Formation integrity tests, casing design loads, cement placement, cement evaluation, and barrier verification all support that judgment. The same applies to drilling fluids. They control formation pressure, remove cuttings, cool and lubricate the bit, support wellbore stability, and reduce formation damage.
But they also create environmental responsibilities. Drilling fluids, cuttings, contaminated returns, produced water, gas, emissions, noise, and surface disturbance all need controls. Solids control equipment, degassing, mud gas separation, fluid management, and waste handling are part of environmental protection. Compliance is the mechanism that connects those obligations to enforceable outcomes. Operators must provide design submissions, operational reports, test records, inspection evidence, and incident notifications.
And regulators verify implementation.
Verification means confirming that commitments are not only written into plans but applied in the field. It includes checking pressure tests, barrier status, equipment readiness, well control arrangements, environmental controls, and records of change.
Enforcement then sits behind the process. If risk controls are inadequate, if reporting is incomplete, or if operations move outside authorized conditions, the regulator must be able to intervene. That gives the life cycle a clear regulatory rhythm. Assess the risks, authorize suitable activity, verify performance, and enforce obligations where necessary. The essential message is that drilling engineering and regulation are inseparable across the well life cycle. Safe and sustainable operations depend on competent design, reliable well control, verified barriers, environmental safeguards, and continuous compliance from planning through abandonment.